Good morning. Suppose that we have to calculate an equivalent resistance of a cube. Cube made of resistors. I'm not going to draw these resistors, but suppose we have a cube, not equal resistors, because equal resistors is easily done, and you can find it on YouTube, many examples, but we are going to do this one to calculate, I think, between the node 1 and 7 and node 3 and 7. Node 4 and 7 is a little bit difficult but possible, but I will do it next time, because we need a new transformation that we don't know. We know star delta transformation or delta star transformation, but from 4 to 7 we need another transformation which looks like this, and we need to transform this one, which looks like this, to this one. It's possible, and I will do it next time. But for the moment, you have to remember only star delta transformation. That's what we're going to use, almost. So delta star transformation, if you remember, I will give you the calculation of star delta transformation. This is for one of these. These are impedances, but we are going to use only resistors, so it means that it will be all over here, there will be R. So Z12 is equal to Z13 plus Z23 plus Z2 over Z3. It means, and we can calculate as well, Z23 is equal to the sum of the Z's that we have calculated here over the opposite, which is Z1. And same thing for Z31 will be divided by Z2. Okay, I'm going to write it here. Let's start. So we're going from this drawing. Okay, so we have 4 stars to transform. Okay, suppose that we have R1, R2, R3, R4, R5, R6, R7, R8. We have chosen the values of R4, R5, 7 and 2, 10 ohms, R12, R9, 10 and 11 as 15 ohms, and R6, 1, 3 and 8 as 3, 8, 1, 6, 5 ohms. Here are 4 stars to transform. So let's take another picture of all of this, what we have to do. I did them in different colors, so that, and I use the equations, transformation, star, delta, transformation for this black, the red one with all the resistors, I calculated, the values are here, the green one I calculated and have values, and the blue one is here and I calculated. It means that between 7 and 1 we have the equivalent resistance, the red one and the green one, 7, 1, 7, 1. We have this one and this one, that will be later in parallel. It's same thing for 7-5. We have 7-5 a blue and a red. We have, for example, 7-3 a blue and a green. We have 1-3 as a green and a black. So it means that between the nodes we have two equivalent resistance. Now, for example, here we have the green and the blue, and we have to calculate the equivalent resistance between these two nodes. I will show you how it looks now. That's the way it looks. Here I try to do it for equal resistance. If we have equal resistance, I will do it later. So it means, as I said, 7-1 there is a green one and a red one. You see? So we calculate the equivalent resistance. It's 13. It's 13.75. This is half. Here the blue and the green, 7-3. Half is 27.5. Here will be half. Here will be half. 5-1. We have a red one and a black one. 5-3 we have a black one and blue, which is violet now because don't have blue color. Here 3-1 is in black and green. So I calculated. So we have one resistance, one resistor here, another one here, another one here, and we still have a star, which we will have to transform later to a delta, and then we can calculate the equivalent resistance between 0.1 and 7, 3 and 7. How did the calculation go? I still have another board here. So this is my board now, new board, and the calculations. The two colors, as I said, the two colors, green and red, gives 1375. Here we have 9.165, 27 and half, 13.75. Here 27.5. Here we have 9.165, and here we have 13.75. Now we have to transform this one into delta, which is the green, and we calculate here these values. I calculate them here with these formulas. And we have 55 here, 7-3 we have 27 and half, and 3-1 we have 82.5. Now the green and the black are in parallel. We calculate the equivalent resistance between the node 1 and 7. It's 11 here. The 2 gives 11. The 2 here will give 1375. And the 2 will give 8.25 here. So we can calculate the equivalent resistance here. It's 11 in parallel with the sum of the 2, which gives 733. Now if you want to calculate the equivalent resistance between 3 and 7, it will be 19.25 in parallel with 1375, and will give 8. Excuse me, I didn't change the point. It's comma everywhere because I did it for the French speaking. So I can say that we calculated the equivalent. Now what I want to do is suppose that we have equal resistances. If we have equal, it means that here the red one will be equal to 3R, the green one is 3R, parallel, everywhere we will have 3r over 2. Here we will have 3r over 2. Here we will have 3r over 2. Here we'll have 3r over 2. This is node 7, 3r over 2. 3r over 2. 3r over 2. 3r over 2. Well, I don't have to draw. 3r over 2. 3r over 2. This is node 1. Node 3. So this we transform it into a delta. So it means that this will give a resistance here that is 3 times bigger, 9r over 2. So we take this one, and here as well, 9r over 2. This one will give 9r over 2, and the 2 in parallel, as I drew them here, that's right. This will give 7 will give 9 over 8r, and now to calculate this one is 9/8 over r in parallel with 9 over 4r, and that's what will give us 3 over 4r as a solution. Okay, I hope that you've understood. It's not so complicated. There's a lot of calculations. I have chosen this resistors, but you can choose any other resistors that you like, and everything will be okay. So, red one, the star, red, blue, green, and black. We have to transform them into a triangle, and we get the equivalent resistance between the node 1 and 7, which is equal to 7.333, and 3 and 7, which is equal to 8.02. And thank you very much.